So we're going to work through finding the antiderivative of a vector valued function now. And I've created one here that isn't too particularly complicated, and I've given it to us in a slightly different form, just to remind us that we have two different versions of a vector, and just that it operates the same as any other vector that we would work from. So here we're after the antiderivative, so we'll go ahead and start writing this out. But what we have is, realistically, we just integrate term by term. So we have 1/3 t cubed in the I direction. For the j direction, it's going to be plus 3. The antiderivative of sine is negative cosine, so it's really going to be minus cosine t in the j direction. And for the k component, we're going to have to take the antiderivative here. It's a little bit of a reverse chain rule problem on this, so maybe you need to do u sub, maybe you don't, but we end up with 6/3 or 2e to the 3t in the k direction. Again, I'll just go ahead and simplify this down at this point. So there's our general antiderivative, but we're also familiar with the idea that we also have to have a constant. So here we need to make sure that we have a plus c, where c is now a vector that represents the constants for all of these. So maybe it looks something like this. And there's different forms depending on what kind of textbook you're working out of. Sometimes they might just list it as ABC, sometimes it might be C1, C2, C3. It's all the same thing, just noting that we know for a general antiderivative, if it's indefinite, we've got to adjust for constants. In this case, again, we have to adjust for all three of our functions within this particular vector. So aside from just using this as an example of an antiderivative and making sure that we adjust for the constants if it's indefinite, we might also consider the possibility that we have an initial value. So maybe we know that at, say, t equals 0, we're supposed to have the value of, I don't know, 0, 1, 1, or something like that. Then we can now use that as a way to determine what that constant is. So at t equals 0, we would take our function here, maybe with our constants, and evaluate at 0, which evaluating this at 0 is 0. So we have 0 plus the constant a. So in the I direction, we would have a. In the j direction, evaluating at 0, cosine of 0 is 1, so this would be negative 3 plus the b. So we would have negative 3 plus b, or b minus 3, for our j direction. And at k, evaluating here at 0, e to the 0 is 1, so we would have 2 plus the constant c. So we would have 2 plus c, or c plus 2. And through our initial value, now we know that that's equal to 0, 1, 1. So then we could just solve out the individual equations. It looks like a is going to be equal to 0, b is going to be equal to 4, and c would be equal to negative 1 then. So now you have your constants and you've solved your initial value problem.